Today's lesson, lesson 4, writing fractions as decimals. Example 2. The reason why it's example 2 because yesterday, example 1 was what?
Simplifying.
Simplifying. All right. And 3/4. The way you convert a fraction to a decimal is you divide 3 by 4, or you divide the numerator by the denominator. So the top number is divided by the bottom number. Now, a lot of your elementary school teachers, including that guy named Baba Mark last year, but my name not Baba Mark, my name is Baba Mark plus 1.
Hey, Baba Mark
So,
plus
no,
1.
no. So, told you that you can't divide 4 into 3, or a bigger number into a smaller number. And I didn't say that last year. I said we didn't teach you how to take a larger number to a smaller number last year. This year, that's our next step in 6th grade. So, 4 divided into 3. Well, we know 4 is larger than 3, so it can't go into 3. So, what you have to do is put a decimal and either 2 or 3 zeros. So, like I was talking to the other class about, my teacher, when I was in 5th grade, 6th grade, just told me to put 2 zeros and never explained to me why I was putting these 2 zeros. Bobby the Rango teacher taught them 2 zeros. My wife's teacher taught 3 zeros. So before I wanted to teach this lesson to you, I wanted to figure out why we're adding these zeros so I can explain it to you in detail. Because my teacher just said do it. Didn't give me no explanation, just said do it. And I didn't want to leave out of here just saying do it. I wanted to give you an explanation behind the zeros. So 4 doesn't go into 3. So what we did was put a decimal and 2 zeros. Now, if you remember from last year, if I wrote this, they're called equivalent decimals, remember?
Yeah.
So basically, this is just an equivalent decimal of 3. I added 2 zeros. But now with the 2 zeros, when I put the 0 here, I also have to raise the 0, when I put the decimal here, I also have to raise the decimal up in the quotient, in the answer. You see that?
Yeah.
Because this wasn't originally here. When I put the decimal here, then I had to put it up here into the quotient. So now I'm taking 4 into 30. You see that, T-Lane? 4 into 30, 7 times. 7 times 4 equals 28. Subtract, bring down the 2. I'll bring down this 0. 4 into 20 goes 5 times. So the answer is 3/4 equals 75 hundredths. Let me explain what type of decimal this is. This is called a terminating decimal. This is called a terminating decimal. And the reason why it's called terminating decimal is because it did what? Terminated. What does terminate mean? Destroy or stop, cease to move forward, right? So we had a 0 as a remainder. Anytime it's a 0 as a remainder, when we're dividing, making a fraction to a decimal, that means we have a terminating decimal. It stopped. Terminating decimal. The remainder is 0, such as the 75 hundredths in problem A, has a finite, and I didn't want to just leave you with the word finite and you didn't know what it meant. Finite means conclusion, number of decimal places. That means it doesn't go on and on and on and on and on and on and on. And sometimes when you use the calculator and you do division, and you know how that number goes on and on and on and on and on and on and on. It goes all the way to the end of the screen on the calculator and you can't go any further. When it does that, it's not a terminating decimal. It's a repeating decimal. A repeating decimal, you can show it goes on and on and on and on. And you can show a repeating decimal in 2 different ways. Either you write 0 and 666 or whatever the number is, 777, 888, 333, and you write 3 dots, dot, dot, dot. Or you just draw a bar over the repeating part. So these are the 2 ways you write a repeating decimal. Our 2 vocabularies, terminating decimal and repeating decimal. So let me go back to this problem. In order to convert this fraction into a decimal, I had to divide the denominator into the numerator. Add a decimal, I add 2 zeros. And this is a terminating decimal because it didn't go on like 5, 5, 5, 5, 5. Any questions on A? Now, when I did some research last night, this little asterisk here next to this explanation of why we add the decimals and the zeros. I add the decimal and the zeros when I divide because my goal is to have a remainder of 0. So I add them and then my goal was met here, right? I had a remainder of what? 0. If I don't have a remainder of 0, that means it's a repeating decimal, and I either write dot, dot, dot after the number keeps on going over and over again, or I write a bar over the top of the repeating number. For example, this problem. I have a mixed fraction, right? But I have a whole number and a fraction. Now, with the mixed fraction, the whole number is easy. I don't have to do anything with the whole number. I can just write the 5 down here in my answer already. That's out of the way. Now, I have to divide the 3 into 2, just like I did here. I divide the denominator into the numerator. Correct, Siani? Add a decimal. I added 3 zeros here. I could have added 2 zeros. I added 3. 3 in the 8, 3 in the 20. 3 times 6 equals 18. And every time I did it, I kept on getting 18 and 20, right?
Yeah.
I would keep on getting the same thing. And the quotient, the answer will always be 6, 6, 6, 6, 6. If I keep on doing it, it will still be 6, 6, 6, 6. So that's called a repeating decimal. Okay. So my answer is 5 2/3 equals 5 and 6, 6, 6, dot, 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 or 5 and 6/10 with a bar over top of 6. Any questions on the explanation? Again, if you memorize this chart, because these are the common fractions you see on your papers, if you memorize this chart, then you don't have to do these steps because you just know what the conversion is already. Make life a little easier. Because then you don't have to do the division if you memorize 2/5 equals 4/10. See what I mean? You can cut it.